Hello everyone. Today we'll learn one of the most important patterns in coding interviews, solving the two-sum problem. By the end of this video, you'll understand first, how to solve two-sum using both basic and advanced methods, and two, why HashMap is so powerful for this type of problem, and three, how to use two pointers to solve similar problems even faster. Four, and most importantly, how to recognize and use this pattern in other problems. So let's get started. Now let's see the problem. Given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice, and you can return the answer in any order. So basically, the two-sum problem asks us to find two numbers in an array that add up to a target number. Let's see an example. Here, if we have numbers 2, 7, 11, 15, and we want to find two numbers that add up to 9. So we're looking for the positions of 2 and 7 because they add up to 9 and their index is 0 and 1. So we return 0, 1. And the important rules are number one, we need to find exactly two numbers, and we can't use the same number twice, and we need to return the positions, not the numbers themselves, and there will always be exactly one solution. And let's solve this the way our brain naturally thinks about it. If I ask you to solve this problem with pen and paper, you would probably first we take the first number and we add it to every other number until you find a match. And if no match, we move to the second number and we keep going until we find the answer. And let's see how this works with 2, 7, 11, 15, and a target, let's say 26. First, we take the first number 2, and we try 2 plus 7, and we don't find the answer. So we try next 2 plus 11, still not, and we try next pair 2 plus 15. And we not find our answer, so we would go to the next number and we try next. We try 7 and 11. 7 plus 11, not our answer. And we move to 7 and 15. We try 7 and 15, still not our answer. So now we start from 11. We try if 11 plus 15 is our answer, and yes, so we have found our answer. And here is how we implement our algorithm into the real Java code. And we need two nested loops to try every possible pair. And first for loop, and which is the for loop outside, we define an index of I, and it starts from 0, which is the first index. And in the nested for loop, we define another index, j, and j starts from I plus 1 to avoid using the same number twice. Let's say int j equals to I plus 1 and j nums. And if we have found these two numbers that add up to target, Let's create a if statement here. If nums I plus nums j equals to target. And here we know we have found our answer, so we return their indexes. And that's it. And if we have tried every possible pair and we don't find two numbers that add up to target, we know that there is no solution, so we return an empty array. Let's try our code. Let's submit it. Now we have it. It took 45 milliseconds and beats about 30% of all results. Why is that? Because let's analyze it. We have a for loop outside and we have a for loop inside. So there is two nested for loops. So it means time complexity is O n square time. And that is not very efficient. For an array of 100 numbers, we might need to check almost 5,000 pairs. Now let's think smarter. For each number, we know what number we have, and we know what total we want. So we know exactly what other number we need. For example, if we want total 9 and we see number 2, so we know that we need 7 because 9 minus 2 equals 7. So instead of checking every number, we can just ask, have we seen 7 before? This is perfect for using a hash map. As we look at each number, we calculate what other number do we need, and we check, have we seen that number before? And if not, we remember this number for later. Let's simulate this. Say we have 2, 7, 11, 15, and target is 9. So we are at 2, and we know that we need 7, and we not found our 7 before. So we remember we have seen a 2, and we keep going, and we are at 7. We know that we need 2, and we know we have 2 before, so we get it. Let's implement this into Java code. First, we need something to store numbers we have seen. The key is number and the value is position. Let's use a hash map for this. And here is it. We have created our memory and we just check every number. And for each number, we calculate what other number do we need. So this needed number is target minus the current number. And we ask ourselves, have we seen that number before? So it means if this scene contains key of that need number. So if that happens, we know that we have seen what we needed before. So yes, we have found our answer and we return their indices. And the first index is stored in the memory is stored in the hash map. And the second index is our current index. And if not have seen that, which means we will remember this number we have seen for later use. And we just put it in the hash map. The key is the number and the value is the index. Now we try our code. Now you can see our code only takes 2 milliseconds and it beats 99% of all codes. And let's analyze our complexity. We just use one for loop, so our time complexity is O(n), and we use a hash map to store numbers we have seen. And in the worst scenario, it will store all numbers. So our time complexity is O(n). Here we traded space for faster time, and we know that it's worth it. Now let's look at a similar problem. 2 sum 2 input array is sorted. The only difference is that the array is sorted. So our first thought might be we could use the same hash map solution. And here it says, your solution must use only constant extra space. So the hash map solution is not allowed here. Now we're trying to explain the ideas of two pointers. We take this for example. We have 2, 7, 11, 15 as our input. And let's say we have a target of 18. And since this array is sorted, so everything on the left must be smaller and big on the right. So the most small element is this. We use a pointer called left, points to it. And we use a pointer called right, points to that. And we calculate those numbers add up. 2 plus 15 equals to 17. And it's smaller than our target. And what we do here is that our sum is smaller than our target, and we try to reach that target. We know that we should make our sum bigger. How to do that? We can move our left pointer. And now our left pointer points to 7. And now 7 plus 15 equals to 22, and it is larger than our target. Now our sum becomes too big. We want to make our sum smaller to reach the target. What we do is here we want make right move left for 1 unit. And now they points to 7 and 11. We try this one. 7 plus 11 equals to 18. And now we have found our answer. Now let's turn our thoughts into real Java code. First, we create a left pointer points to the first position, and we create a right pointer points to the last position. While left is smaller than right, it is imagine it like in a long hallway and two people, one at each end, and the two people walking towards each other while they don't converge. And once they converge, this is over. And while they don't converge, let's calculate their current sum. And if sum is equal to our target, we know that we found it. So we return the indexes. And here, notice that our output is 1, 2 rather than 0, 1. So this problem is based on 1 based indexes. not 0. So we just add 1. We return new in left, right. And here we just plus 1 to each one of it. And else if our sum is larger than target, which means our sum is too big. And since the array is sorted, how do we smaller our sum? We just need to move our right number to the left, so our sum will be smaller. So right, move one index to the left. And else if our sum is bigger, it's smaller than our target, which means our sum is too small. And on the contrary, we will try bigger our left number. And we tried our solution. And you see that this is even better than HashMap solution because we don't need extra space. And why we can do that? Because this array is sorted, so we can use the two-pointer solution here. And here are some key patterns to remember. First, for unsorted arrays, think HashMap. What HashMap can do here, it is called the complement pattern. It is that instead of looking two things directly, look for the complement of what you have. This pattern can appear in many other problems, like finding pairs that sum to 0, finding pairs that multiply to a target, and finding pairs with a specific difference. All their similarity is that once you fix one number, you can know exactly what the other number you need. So you can use a hash map to store something that you have already seen. And for sorted arrays like this one, you can try think two pointers. And if you are ready for more practice on two pointers, you can try these problems. The first is container with most water. Here you are required to use two pointers to find the container that holds the most water. And the other problem is threesome. Here are the tips. You sort the array first, then use one number as target, and find pairs that add up to target. Both use similar thinking to what we have learned today. And that's all for today. Now you know how to solve two-sum problems, and you know how to use hash maps for faster solutions. And you know how to use two pointers when arrays are sorted. Practice those patterns and they will become natural to you. And don't forget to like and subscribe and leave a comment below for more coding tips. Next time, we'll look at sliding window problems. See you then.